So if you're building with large language models, you are almost certainly using an LLM-as-a-Judge system to speed up your evals, right? And it feels great. Your dashboards are all green, your team is moving faster than ever. But what if you're flying completely blind? Today, we are going to dive into the 5 hidden biases that can quietly, totally sabotage your AI development and actually lead you to optimize for failure. Let's make sure that doesn't happen. And this, right here, is the perfect way to think about the risk. Your LLM Judge, that's your altimeter. It gives you that fast, scalable feedback you need to navigate. But what if that instrument is flawed? It might be telling you you're climbing when you're actually nosediving straight toward the ground. Relying on a biased judge means you could be shipping regressions, hurting user trust, all while your internal metrics look absolutely fantastic. So here's our flight plan for today. We're going to start by understanding the risk of flying blind. Then we'll diagnose 5 really critical biases. And finally, we'll talk about how to build a resilient system and give you a clear action plan. Let's get into it. All right, part 1. Flying blind with AI judges. Let's talk about the real risk of using a faulty instrument. Okay, part 2, superficial flaws. We're going to kick things off with 2 of the most common and maybe most obvious biases you'll run into: position and verbosity. First up is positional bias, and it's so simple it's almost silly. The judge just kind of likes the first thing it sees. So let's say you're A/B testing 2 different prompts. If you always put prompt A's response in the first slot, the judge might just keep picking it, not because it's actually better, but just because it's first. And just like that, your entire experiment is completely useless. It's all noise, no signal. The good news is the fix is just as simple. You just run every single comparison twice. The second time, you swap the positions. You only accept the result if the judge picks the same winner both times. It's a really straightforward check that filters out all that random noise and makes your results way, way more reliable. Next up, we have verbosity bias. This is where the judge gets confused and thinks longer means better. A model might drone on for 5 paragraphs when the perfect answer was just 2 sentences. And the judge gives it a high score for being comprehensive. The danger here? You accidentally train your models to be annoying and long-winded, which just frustrates your users. So to fight this, you have to get really explicit in your prompt engineering. You need to tell the judge exactly what you care about. Add instructions to your system prompt like, hey, penalize responses that are unnecessarily verbose. You are basically teaching it to value conciseness and substance over just, the sheer number of words. Part 3, false signals. Now we're going to dig into a couple of sneakier biases: nepotism and authority. These are a little more deceptive. So this one is technically called self-enhancement bias, but honestly, everyone calls it nepotism bias, and for a really good reason. A model like GPT-4 judging a competition will have a natural preference for answers that feel like they came from the GPT family. It's not because they're better, but because they share the same kind of stylistic DNA. This creates a really dangerous evaluation echo chamber, and it makes doing fair head-to-head comparisons between different models almost impossible. And the solution for this is exactly what you do in the real world to avoid nepotism, right? You bring in a neutral third party. So if you're trying to compare a model from OpenAI against one from Anthropic, maybe you should use a judge from Google or another provider entirely. That's how you get a truly impartial signal. Now, this one is really insidious. It's called authority bias. This is where the judge gets impressed by the appearance of credibility. A response might confidently claim, according to a 2022 Harvard study, even if that study is completely made up, and the judge will rate it higher than a correct answer that doesn't cite a source. This is so dangerous because you're literally training your models to get better at hallucinating plausible-sounding fake sources. The way you fix this is you fundamentally change the judge's job. Don't ask it, does this sound authoritative? No. Instead, you give the judge the actual source document, and you ask it, is this claim right here factually supported by this specific text? This forces the judge to actually verify facts, not just get impressed by confident-sounding language. Okay, on to part 4, the alignment trap. This is where we get into the really subtle stuff with what's called moderation bias. So what is moderation bias? Well, these LLM judges have been trained so heavily on safety alignment that they will often reward a polite refusal. I'm sorry, I can't help with that. It gives that a high score, even when the user's query was actually pretty reasonable. A real human, on the other hand, would probably find that same refusal to be super unhelpful and just plain frustrating. Now, this is the one bias that you really can't just prompt engineer your way out of. The only real fix here is to bring a human into the loop. You have to set up a workflow that automatically flags any evaluation that involves a refusal and routes it to a person for review. It's the only way to keep your judge calibrated to what real people actually find helpful, and it stops you from building a product that's so safe that is basically useless. Okay, part 5, building a resilient system. We've talked about fixing individual problems, but now let's think bigger. Let's talk about architecting a truly robust evaluation system from the ground up. We can do this with 3 key principles. First, use an ensemble of judges. Think of it like a jury. You get several different models to vote, and their individual biases tend to cancel each other out. Second, you run self-consistency checks. Ask the same judge the same question a few times, maybe with slightly different phrasing. If you get different answers, that's a huge red flag for instability. And finally, and this is the most important one, you have to calibrate everything against a golden dataset. This is your ground truth, a set of examples that have been meticulously hand-labeled by your own human experts.
All right, final section, your action plan. Let's turn all of this theory into something you can actually do tomorrow.
Here are your next 4 steps. 1. Audit your current LLM-as-a-Judge prompts and your whole process. Look specifically for these 5 biases. 2. Start implementing fixes. The easiest one with the highest impact is position swapping, so start there. 3. Get to work building that golden data set. This is absolutely critical, so sit down with your domain experts. And 4. Share this stuff with your team. Building an awareness of these issues is the first step to building a culture that values truly high-quality AI. So, we end up right back where we started, flying through the fog. Look, these biases we've talked about, they aren't weird edge cases. They're fundamental properties of the tools we're using. But by understanding them and actively working to counteract them, you can turn that faulty instrument into a tool you can genuinely trust. So the question I want to leave you with is this. Is your altimeter trustworthy?